pure substances, and formulations. In chemistry, a pure substance consists of only a single element or a single compound that's not mixed with any other substance. Pure substances can be easily identified because they melt and boil at precise specific temperatures. In contrast, a mixture does not have a sharp melting point. It will melt or boil gradually over a wide range of temperatures. A formulation is a very specific type of mixture that's been carefully designed as a useful product. In a formulation, every single ingredient is measured out precisely to ensure the product has the exact properties required. Examples include paints, medicines, alloys, and fertilizers. In the exam, a pure substance melts and boils at one fixed temperature. A mixture melts and boils over a range. This is the simplest way to tell them apart from a data table. So a formulation is a recipe. Every ingredient is measured out on purpose to get the exact result that you want. Chromatography. Paper chromatography is a method used to separate a mixture of soluble coloured substances, such as the different dyes in an ink. You draw a starting line in pencil near the bottom of the paper, place a spot of the mixture on it, and dip the bottom of the paper into a solvent. The solvent travels up the paper, carrying the different substances with it. Substances that are more attracted to the solvent travel further up, while substances more attracted to the paper travel less far. So the mixture separates out into individual spots. In the exam, always draw the starting line in pencil, never pen. Pencil is insoluble, so it will not run up the paper and ruin the result. A pure substance produces only one single spot, whereas a mixture separates into two or more spots. RF values and required practical. Chromatography. Each substance can be identified by its RF value. The RF value is calculated using the formula RF equals the distance moved by the substance divided by the distance moved by the solvent. Because it's one distance divided by another, an RF value is always a number between 0 and 1, and it has no units. In the required practical, you separate the colours in food dyes or inks, measure both distances carefully with a ruler from the pencil line, and calculate the RF value for each spot. In the exam, always measure to the centre of each spot, and always measure both distances from the same pencil starting line. The same substance will always give the same RF value in the same solvent, which is how you identify it. Testing for gases. There are 4 common gas tests that you must know. To test for hydrogen, you hold a lit splint at the mouth of a test tube. Hydrogen burns with a squeaky pop. To test for oxygen, you place a glowing splint into the tube, and oxygen relights the glowing splint. To test for carbon dioxide, you bubble the gas through lime water. Carbon dioxide turns the lime water cloudy or milky. To test for chlorine, you hold damp blue litmus paper in the gas. Chlorine bleaches the litmus paper white. It might turn red first because chlorine is acidic. In the exam, learn these word for word, including the result. Squeaky pop for hydrogen, relights a glowing splint for oxygen, turns lime water cloudy for carbon dioxide, and bleaches damp litmus paper for chlorine. The early atmosphere.